Hello and welcome back, everyone, into this fifth chapter of Module 3, where we're going to wrap this up, entire module, and move on to the next one. In this chapter, I'm going to be talking about the different elements of programming, okay, which is going to be high-level programming, low-level programming, and simulations. In a robotics system, you would come across different levels of programming depending on the complexity of the robot and depending on the use case of the robot, okay? If you're buying a robot, chances are that you might have to do a high-level programming rather than a low-level programming, which means that you have much more simplified things, and then you can implement things much more quickly. However, all of the decisions are actually tuned and checked when you are working with a robot, and when you have multiple conditions and situations. So it makes the whole process quite tedious if you're not sure which level of programming you're working on. So in this video, I'm going to be effectively telling you, which ways are there, all of the processes which are there, and which one will work really good for you. So without any further ado, let's actually jump into this video and see what do we have. So we are going to move ahead from this chapter, and we'll move on to the next slide. Programming for robotics refers to the process of creating software programs that control the behavior of robotic system. So you have to essentially design softwares or programs that are going to affect the robot and make them move. Programming for robotics involves selecting the appropriate programming language and frameworks to enable the robot to perform specific tasks. Types of programming for robotics. There are several types of programming for robotics which are used in robotics, including low-level programming, which means a level of programming that involves writing code directly into the that interacts with the robot, such as microcontrollers or sensors. Low-level programming can also be used in for real-time and high-performance applications. Since you're optimizing the task all the time, okay, low-level programming is the most optimized version of programming. Then you have high-level programming, which is effectively involved in writing code that abstracts away the details of the hardware and focuses on the behavior of the robot. Okay, we are going to focus on the behavior of the robot. Then you have high-level programming, which is commonly used for complex behaviors such as navigating, decision-making, and machine learning. Okay, this is effectively making things much more easier for you. Okay, in terms of implementation, not in terms of decision-making, but in terms of implementation. Okay. And then you have the third one, which is simulation, which involves creating a visual model of the robot systems and testing the behavior in a simulated environment. Now, when I say simulation, it means nothing is going to be physically present. It's all going to be in the software. Simulations are commonly used in robotics for testing, validating a robotic system before deploying them in real world. Okay, before you actually deploy them in real world. Programming for robotics is important because it enables the robot to perform specific tasks and exhibit sophisticated behavior. It's like a very mixed situation. You want to implement something, you want to, have a task which is there. So all of these things quite, overlap with each other, making the robot system quite independent. Programming for robotics allow for robots to interact with complex environments and calculation and make decisions. Okay. So effectively, the better the program you have, the better your robot is going to behave in different conditions. Example of programming is going to be, used for low-level programming in C, assembly for real-time in low-level robotics. Then you have high-level, which is Python, Java, developing complex behaviors such as navigation, decision-making. Simulation, MATLAB, ROS. We already talked about ROS a little bit. MATLAB is another mathematical software to test and validate robot behavior. And that concludes it up. Now, this PPT actually is like covering very little. It is like talking and telling you about this. So when you take a robotic system, okay, you usually have a set of rules that are already there in the firmware. Okay. Now, if you buy a robot, definitely it's going to be much more easier for you to program it. If you don't buy a robot and you build it on your own, okay, it's very important for you to understand which language you're working on. Arduino basically is like a bridge that makes your high-level programming into a low-level programming, which means you only need to tell Arduino what all things you have to do, and then Arduino is going to take care of it and do it itself. Okay, so you don't really have to think about, okay, that this is something that I want to do, that is something that I want to do, and how do you program it at a lower level. Of course, there are limitations in terms of performance. Arduino takes a lot of time performing things. But effectively speaking, when you are working with controllers, that's what you have to keep in mind, okay? That your controller and your devices are pretty much, yeah, sorry. So your controllers and devices are pretty much independent, and they can take care of the data, and they can work in a much more independent way. all the time. Okay. And this is only possible if you have a high level programming and a low level programming interface. Of course, if you have something which is like a very high performance device, okay, then you might not need to work in Python or C, C++. You can directly work on something with like a low level language, which is going to be a little complex, but very effective in terms of optimization. Now, this is all good. We finished upon the module 3, which is really powerful. Next module is going to be all about talking and diving into the facts of programming. I hope all of you are excited, and we're going to start working on simulations in Tinkercad, and it's going to be a lot of fun. I'll see you all in the next one. Till then, happy learning.